Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond. We're talking with Rethink DB today. And we have on our panel Justin Ribeiro.
Hello, wonderful people. So good to see you after missing you last week.
And I'm Eric Isaacson. And today we are joined with Michael. I'm going to totally blow your name up. Is it Glukhovsky?
That's pretty good. Yeah, Mike Glukhovsky. In Russian, it's Mikhail Zakharovich Glukhovsky, but we're not going to ask you to do that.
You can ask, but there's no guarantee that's I can barely say my last name.
Yeah, I get all sorts of stuff with Isaacson, but that's.
I know, right? It's a good one, yeah. I'm one of the founders of Rethink DB. I've been building Rethink with my co-founder Slava for the past 7 years, and a team of incredibly passionate open source developers here in Mountain View, California. So I'm happy to chat about platforms and Rethink DB and what we're building with Horizon.
Excellent. And so we've seen you on a couple of different podcasts, and you were at NGConf recently, and you talked about Horizon, and Slava too, who couldn't join us today, but he wanted to. He was under the weather, but you guys founded it together. How did this all come about? Did Slava come later, or how did this work out?
Yeah, Slava and I met. He was doing his PhD in computer science. I was doing my undergrad at Stony Brook University back on the East Coast, and we met, and we decided that we wanted to take advantage of some really low-level changes that were happening in the hardware space, specifically solid-state drives and multi-core CPUs. So we started out, our backgrounds, his is distributed systems. Mine is user experience and design, which is a very interesting combination of how you get Rethink DB from both sides of the equation. But we're trying to figure out if we could build software systems like databases that would capitalize on really monumental shifts that happen in hardware and make them really usable and interesting for people to interact with. And as we started to build the architecture for Rethink 7 years ago, it became exceedingly clear over time as we started to build more features and go up the stack that the kind of things that people really were using Rethink DB for, building real-time apps that consume tens of thousands of streams that can scale across 30 to 50 plus node clusters. It stemmed from the fundamental architecture we built together. But it also, we designed it to be an incredibly usable system because that was the DNA we put into it from day one. So it sort of came out from us just deciding we wanted to go tackle really hard problems together. We applied for a seed fund from Y Combinator for an initial funding to get us out to come to California to start to build it. And from there, we just started building our team and growing Rethink DB.
That must have been pretty crazy.
Yeah, that is an understatement. Yeah.
So with Rethink, it's a little difficult for me to wrap my head around what exactly it is. And we have two things we're talking about, right? We're talking about Rethink DB and Horizon.
That's right.
Right. So there's two separate things. And can you explain what each one is and how they solve problems for the web today?
That's a great question. So, Horizon is a new project from the Rethink DB team. So before we talk anything about Horizon or discuss why it's interesting or exciting, it's important to talk about what Rethink DB is. So Rethink DB is an open source distributed database. It's a document store, so you can store JSON documents in it. We chose that as a document model because JSON, for better or for worse, is the data interchange format we picked for the web. And it allows you to define things in a schema-free fashion. It's easy, human readable. But fundamentally, what Rethink DB is so at this point, it's the #1 database in terms of stars on GitHub in its category. And it basically, the reason that it has so much attention is that it has two properties that are really exciting. One is that you can linearly scale out nodes in the clusters. If you want to scale your clusters, it's very easy to do it. You can shard, you can replicate, you have automatic failover. It's the kind of system that was designed to work at scale. One of the largest online brokerages in the world runs 25 million users on their web and mobile apps every day on a 25-node cluster in 3 data centers. So the system has been tested at scale by a lot of folks in the industry. But the thing that's really exciting about it, because good architecture aside, the thing that is fundamentally different about Rethink DB from every other database is that in Rethink DB you can write a query. In a normal database you would write a query and get a response. And if you wanted to stay updated on the value or on the result of that query, you'd have to rerun that query periodically. This is called polling. And polling is notoriously inefficient, and it doesn't really help you understand what's happening within the system at a deep level, because if you're doing it at scale, you have to be careful of how many actions are polling the database. In Rethink DB, you can write a query and then open a stream and then get pushed updates on that query as new documents come into the system that affect that query. This is incredibly powerful and potent because with these streams, you can, as I mentioned, you can open tens of thousands of these streams on a single node. You can scale it out linearly from there. You can open millions of these streams in your cluster, and you can have all of your clients, all of your applications receive stateless updates from the database. So what it does is it enables a class of applications that were previously really challenging to build. We call these real-time apps, and what we mean by this is that think Google Docs, think Slack, think IoT, streaming analytics. In all of these use cases, the thing that's happening is that clients are exchanging data with each other, and that they rely on having real-time updates coming from the database or some backend. And what you want is you want to be able to have, to build these kinds of applications without having to write lots of code that figures out how to route messages, how to figure out how to keep track of the data that's changing in real time. In Rethink DB, you can just open each what we call change feeds, these streams to the database. You can open a lot of them, and it makes it dramatically easier to build this whole class of applications. So if you want to build anything where you're trying to stay updated on values, real-time apps that deal with marketplaces or chat, IoT, streaming data from multiple sources, it's really hard to figure out how to push data to the client. And so in Rethink DB, because it starts from the database, because these streams are so fundamental, they're going all the way down to the cores in the CPU, it's extraordinarily efficient, and you can open these streams on any query. You're able to build these kinds of applications with dramatically less code. Does that make sense the way I've explained it?
Yeah, I'm surprised you haven't chose XML, instead of JSON. It's so beautiful to look at.
I'm not a fan of XML personally.
Yeah. As far as like that goes with the streams.
Yeah.
I mean, it seems like the React community and Angular have really embraced Rethink. Yeah. Is there like integration with like observable type of structures?
That's a really good question. So it's interesting because if you look at what the modern stack looks like, right? So at the front end, you have React or Angular. We used to use things like jQuery to sort of move bits around the page, and we've sort of progressed and used real principles of software architecture now. We have components and views, and we have like unidirectional data flow that stems from the root components, or even further in your backend. And then data flows and ripples up, and it affects views that will statelessly update themselves in reaction to state changes that have happened at a low level. This has been huge for front-end architecture, and it enables really complex applications instead of just your traditional jQuery enabled apps that are fairly simple. If you look at the back end, Node.js is huge in the web world. And it's not just because it's JavaScript. JavaScript is amazing because it's just arrived on like any platform you can imagine. There's JavaScript available for you. But the reason why Node is really exciting is not because of the JavaScript, it's because it's massively asynchronous, massively parallelized, designed for lots of data that's updating in real time, lots of streams. And up until now, the backend components, things like databases, things that are running in the backend, they haven't been enabled for these, real-time, use cases. You haven't been able to open streams from the database. So you have to have a lot of code and a lot of like architecture, things like message queues, like using RabbitMQ or Kafka to shuttle messages around, or things that will watch the database and pull it to sort of push out updates. These are all patches to what we really want, which is a massively asynchronous, massively parallelized database. And so Rethink DB is really the first massively asynchronous parallelized database. And it's designed for this world where you have Rethink, Node, and then modern web frameworks that use these principles of software architecture.
I know that when I get asked about Rethink, because I've given a talk to you guys to meet up in San Francisco. Great meetup, by the way, in San Francisco. Check it out. People often ask, well, is it based or derived from something else? And you guys wrote this from scratch in C++, correct?
That's 100% right. So actually, the code for C++, Rethink DB is not based on any other project. We started by building the storage engine, the lowest level components. So when you look at the code that C++ that the Rethink DB encompasses, it's all written in modern C++, and it goes all the way down to a custom coroutine engine we built for cores in the CPU to enable massive async operations. And so basically, if you look at the stack that Rethink DB encompasses today, it goes all the way from assembly to JavaScript, and that's about as full stack as you get.
And you said real time, and when I think of real time, I think that a lot of applications, especially in line of business applications, you don't necessarily need real time. You would need real-ish time. Is there other advantages to using Rethink DB? in those particular cases, like where you don't have static content, but you have content that gets updated, but it's not very often?
Right. So the real-time updates are really nice when you want to offer like a good user experience. You need certain guarantees in your environment. I can talk about like how some of those cases actually pop up in non-traditional, like not just web apps, like they show up in a lot of different other areas. But fundamentally, RethinkDB is still incredibly useful and powerful as a general purpose database. So it's a very good general purpose like document store. So it has an incredibly flexible query language. It's not designed in any other language. It's basically a complete functional composable programming language. But it embeds into native code. So it looks like JavaScript, Python, Ruby. If there's name a language, there's a driver for it. If you want Erlang, Lisp, Haskell, Go, Java, there are drivers for all those environments. And the way it looks is that, in SQL, you would write a string that would basically send over like the SQL query, then run it on the cluster, and then come back. Run your database and come back to the user. In something like MongoDB, you would send over a JSON object that represents the modification you want to make to your database. And you use these sort of magic operators to indicate the updates that you want to make. In RethinkDB, it's just native code. So what happens is that we use a chainable API, a fluent API. So an example of a query would be like R for RethinkDB, .table, .filter, .map, .reduce. And then, what you end up with is this chain, and in each element in the chain, you can also use complete functions. So what's really amazing about this is that it feels just like you're writing native code, except all of those functions are getting run on the server in an efficient, distributed fashion. And what's great about this is that it allows people to rapidly prototype, different data models, to write the kinds of queries, really programs that are running on the cluster, but to write the kind of queries that you really couldn't accomplish before. So, just to be able to deal with messy, fuzzy data, our initial perspective was like, we want it to feel like Mathematica, but for JSON, to feel like you really can explore disparate data sets and really understand what's going on, and have a really fluent, flexible query language. But when you actually start to like get, experienced with REQL, or we call the query language REQL instead of SQL, when you get experience with it, you can build some truly amazing things. So people have built like complete recommendation engines. They've built like real-time risk analysis tools, like in REQL purely, that run on the cluster for like financial models. And this is enormous for people who basically want to deal with lots of disparate changing data sets, or just like have a lot of JSON and don't know how to work with it well.
Now this is all open source, right? And
that's right.
And like with something like software as a service, having like a backend as a service, actually like Firebase, right?
Yeah.
One of the disadvantages to Firebase, and there are many advantages over it,
yes,
to use that. But one of the disadvantages I found is you have to actually use the service. You can't actually host it like I think Apache has a backend as a service that you could actually host yourself. So is there like, can you and would you, for certain cases, use Rethink, internally, rather than using the service? Obviously, I'm sure you have a good business plan, and people would want to use your service, but could you do it internally? Is I guess the question.
You mean, can you self-host your own stack? Can you roll your own environment?
Exactly. Yeah.
That's
Thank
the
you
primary.
For shortening my thought. So it's
You're
good.
doing great. Yeah. So it's interesting because we have like a great partner at Compose.io who runs like hosted RethinkDB instances, and they've been doing it for a while. But the thing is that tools are really good in deployment nowadays. So Kubernetes is one of the most exciting projects I've seen like in the past like few years for sure. And what's amazing about it, the idea of containerization, no matter what container model you pick, the idea of being able to spin up these workers as stateless workers and then just be able to deploy them across instances is incredibly compelling, and Kubernetes is really powerful software for doing that. So running RethinkDB on your own server, I mean, to install it, apt-get install Rethink, brew install Rethink, really easy to get up and running. You can easily add nodes. If you wanted to then deploy it using something like Kubernetes to have like a real like production instance that's capable of surviving like any disconnects and things like that. There's a lot of great tools that are now available for you to compete with the flexibility that something like Firebase or AWS or the other service would provide. Having said that, sometimes you just want to have other people deal with the operational burden, and so there's like whichever way you want to go is good for you. But the thing is, open source, like when it comes to infrastructure software, I believe open source tools are absolutely the way to go every single time, because it's not just that you're getting to use a product that fundamentally is open, that has a future regardless of what service you're tied to. But beyond that, you have a community, and open source is the kind of thing where people will just start to build things around it, and they'll start to support it in ways and extend it in ways you would never expect. And that has been nothing but a blessing for Rethink DB. And that's where the Horizon project has really stemmed from, is because the community has taken what we've built, this open platform. We do everything on GitHub. Everything's straight out in the open. And just opened issues has told us we need to pull it in this direction. And from that has stemmed the Horizon project they're working on right now.
All right, I think that's a good segue right into Horizon. You set yourself up for that, so go ahead on that.
Yeah, sure. So Horizon is a new project that we started building about 6 months ago. We had a developer preview where we had close to 2,000 developers working with us on a closed project on GitHub, where we basically were building the next thing that developers asked us for after Rethink DB. So the thing about Rethink is that it makes it like dead simple to build like all these real-time apps. But when you tell somebody, you get these streams, these change feeds from the database. When you tell somebody, you should go build Google Docs or Slack or some other system, the thing that they ask you is, what do I do next? Like a lot of people just wanted to take the change feed and just open it straight in their browser. And we said to them, don't do that. You don't open a database connection straight from the browser. You need something sitting in between to mediate and do access control and authentication and things like that. And so
I've been doing it all wrong all these years.
Exactly. There you go. The thing is, the first time this happened, we were like, okay, don't do it that way. At the 50th time someone did that, we were like, maybe we need to think about this a little more carefully, because clearly developer expectations from developer tools have like shifted. And the answer we give to people when they ask us, what do I do next? It's go install Node, go install Socket.io, go use WebSockets, go install a bunch of tools to do authentication and access control. And it turns out that's like a lot of work. And our JavaScript community has been like the most passionate from all the language communities that we've had. They've really embraced it. I think because of the reasons you mentioned, like tools like React and Angular have driven new ideas on how to build software. And so they asked us, like, hey, can you just try to integrate new tools like GraphQL, or like try to add more features to the database that are for the JavaScript community and that would really help simplify building real-time apps for JavaScript. And we realized that we needed to build something on top, something to basically help all of the JavaScript developers figure out how to get started with JavaScript, how to really build a real-time app with a minimum of code. And so Horizon, it's a new project that's on GitHub, and it runs on top of RethinkDB. It uses RethinkDB's two properties, linear scale and real-time push. And it capitalizes on those to basically provide a complete open source real-time backend. You can think of it as something like maybe Firebase on your laptop, or some backend as a service, but running on your laptop. What it does is it's a standalone server that exposes a WebSocket connection by default. You consume that connection from your browser, and using a simple API that's based on observables, RxJS, you can consume streams that are coming from the backend. And you can open a ton of these streams. And what the backend is doing for you is, besides shuttling changes from the RethinkDB database under the hood to collections in your browser that are magically updating themselves, it also provides a set of convenient APIs and tools that are designed to make it dramatically simpler to build JavaScript apps. So every time there's a common pattern, like boilerplate code, that 90% of apps really share in common and you don't need to innovate on. Things like identity, access control, session management, all the different like sticky issues that come up when you're building a mobile app or a desktop app or a web app. There are things that we just keep repeating and reinventing the wheel over and over. And the Horizon API gives you a sane default to allow you to get up and running really quickly. And then, because it's just written in Node.js, it's also a series of Node.js modules that when you're ready to extend beyond what the API can do, you can just extend it on the back end and just import the whole stack as Node modules. And so what this means is that it gives this vision of building software where basically you can rapidly prototype your app in your browser using modern tools like React and Angular in just the browser. And when you're ready to extend, you can extend on the back end. And then using RethinkDB Scale, you can scale it to millions of users. And because RethinkDB is doing all the heavy lifting, the Horizon layer, Horizon, is really just a way to make it convenient and simple for people to consume things from JavaScript. It feels like a really beautiful experience in JavaScript, but at the same time, you get to use the entire RethinkDB ecosystem. And when you're ready, you can still just write to the database, and you get a full environment ready to run on your laptop.
And on that stack, I mean, you talk about sort of building on top of what Rethink has, because Rethink, in terms of its scale and the things that it does, I mean, it has write durability, it has atomic transactions. A lot of that stuff is things that we necessarily want out of a database, but don't necessarily understand. I mean, does Horizon sort of extrapolate away some of the design decisions that a developer might have to make? Does it make it simpler to sort of build that infrastructure using Horizon quicker, possibly?
Yeah, so the thing that we found was that when we started to talk to people about using RethinkDB to build aspirational apps, like things like real-time app that they really wanted to build, they didn't want to think about the database. Like the database is this thing that people have tried to pull away from, both because it's confusing and complicated, and you have to really understand these things in sometimes quite subtle manner to figure out in a distributed environment in particular how to perform operations that would otherwise be difficult. And like deployment's challenging, and the tool chain is different from what you're using on the front end. And so what often happens is that people start out from the JavaScript environment. They want to build something in React, and then they find themselves being dragged down the stack until finally they're setting up a database, and they're like, how did I end up here? All I wanted to do was build a React app. And Horizon just removes all of that. And the goal is basically that you shouldn't have to think about these things for the majority of common cases. And Horizon abstracts away all of those sort of details for you and gives you simple APIs to use instead. But there's still the power of the database for all the things you mentioned under the hood if you choose to access, if you choose to work with it.
So on that note, the best practices and concerns, if people are used to using MySQL, for lack of a better example, there's certain ways you'll design how you're actually grabbing data, how you're putting data in, and a lot of times you're right. Like as front-end developers, I know myself, I try to just let somebody else worry about the data. I just need to know how I need to pull it in and to push back to it, right, via some API or whatever. But I mean, what can people do for their apps if they need something like a Rethink for general purpose or for real time? What are the best practices or the design choices, good examples of these that we can use to kind of go through our app and make it better?
Yeah. So one big change that is not intuitive for people who get started with RethinkDB. RethinkDB is termed a NoSQL database because it's a document store. I think NoSQL is a ridiculous term, not because it's not a category, but because it's kind of like horseless carriage. It's the absence of a technology. It doesn't define what it is, and a lot of things go under that heading of NoSQL. And things like document stores, graph, key value. And the thing is that from most document stores that people are familiar with, the most NoSQL databases, they aren't capable of doing distributed joins. So in RethinkDB, you are able to do distributed joins because of the architecture that we built, that it's fundamentally parallelized. So not unlike MySQL, but rather unlike other systems like MongoDB or other databases that don't have joins. You do want to use tables. You want to be able to join your data on the fly. You want to be able to run these kinds of queries, and you don't want to denormalize your data in a way where you're creating very deep documents that you shuttle over to the client and do application-side joins. So that would be the one thing that I would definitely advise developers who are getting started and with Rethink, is that they might think that they need to just create really deep JSON documents. But actually, we call our collections tables. We treat it very similar to a SQL system. You get most of the properties you get in a SQL database, group bys and map reduce functions at the same time. Different things you might not expect in dissimilar items in a database. But being able to put your data into different tables and join them is incredibly important. And we're adding the ability to actually do real-time streams on those joins as well in a future version of Rethink, which will be very exciting, because then you can just join any bits of data together and just open a stream on it. I'm trying to think if there are any other specific considerations I would give for a developer getting started with Rethink. I would definitely say that if you're moving from MySQL, you don't have schemas. So you have to write your queries in a way that you just have to be aware of the fact that you may have missing fields. And so we have tools for solving these problems. In the query language, there's a term called default. Default will basically, if a field is missing, it'll just say, if it doesn't exist, just use this as the default. This is the advantage of writing a query language that uses a fluent API, is you can embed commands and terms that will help the developer reason their way through the query and just think about different cases as they're writing it, instead of these sort of complicated objects. The other thing that I would consider is that if you are dealing with other database systems, you may not be familiar with the fact that Rethink has things like branching or looping. It is a full programming language, as I mentioned, so you actually are able to do conditional statements in a way that you might not be able to in other systems. And so as you get started, you need to understand that in RethinkDB, the query gets executed on the server. You write it on the client. Then gets compiled down to a distributed expression, then pushed out to the cluster executed in an efficient distributed manner. Data goes to every single node, then every core in the CPU, then down to disk, and bubbles back up. And all of these operations will then come back with the result. So oftentimes people will get started from the client, and they'll be like, oh, I expect that it's running on the client, and try to use like console log or things like that inside of the JavaScript query. And you have to understand that it's going to get executed once on the client to parse the query, and then it's going to run on the server, and it's going to do the efficient distributed operation that you expect. And it's very simple once you understand this, because there's a magic term that you drop at the end of your chain called .run. When you call .run, it's going to take the whole chain, and it's going to push it up to the cluster and come back with the result. These are probably the most non-intuitive, basic getting started details, but none of them are challenging to get up and running with. It's just you have to sort of do a little bit of a context switch once you start to write apps for Rethink DB.
Yeah, and Rethink's really smart in that too. I mean, you don't actually have to target. If you have a large cluster that's running, you don't have to be specific against your queries, right? You can just throw it at the cluster. It's going to figure out exactly what to do without any issue whatsoever. It actually makes it, again, to your point, it makes it very scalable. You don't have to worry about where things are necessarily. You simply need to understand the language and how to query against it. And you bring up a valid point too. I think it's a shame because there are so many database systems that exist today that everyone tries to compare them, apples to apples. And I think Rethink and Firebase and PubNub and 27 other gazillion ones that are out there, they all have strengths and weaknesses. And it's actually one reason I really like your guys' FAQ.
Yeah.
Because you speak to about 300 gazillion misconceptions about, well, actually, that's not what that one does, and it's good for this. And we're good at this. And there can be a lot of developer confusion when it comes to how these systems actually operate at the end of the day and how you as a developer leverage that to get the performance that you need.
That's right. And it's important because these guarantees can be quite different than you expect. And so when people's marketing pages will promise unifying like a bunch of different disparate ideas, it's important to educate and understand that there are certain fundamentals that might get in the way of that. And so you want to be able to pick the database for your tool, for the job. You always want to use the right database for what you're building for.
A lot of times you're using multiple data sources, right? So you may have, you might be using Mongo for one thing, you might be using Rethink for another, depending on the sections. If you have some large, massive, application, it might be broken out into little multiple applications that use different data sets. And so getting that stuff synchronized together, that's also another challenge in itself.
So interestingly, there are two things that I would say that I've noticed come up in past years. So one is an event sourcing model is excellent as a data model choice, where you can basically attach timestamps to all of your documents, and then you can know that you can at least have them in the system or not based on the timestamps. And so you can look up event sourcing patterns where you can basically shuttle data around between multiple data sources. But I will also say that by having RethinkDB have real-time streams that will push out updates, a lot of people use Rethink as the core database. Then they will push updates to things like Elasticsearch to do full text search or other databases to keep it in sync. If you think back to the principles from React and Angular, you want a universal source of truth. You want to have a place where you basically know that you have the definitive data set. Then everybody else will have maybe a lag, but at least you know that there's one place you can always go to that has a definitive result. And so RethinkDB often is used at that core because it can then push out updates to every other system that needs to get updated after the fact for other use cases and other needs.
Yeah, that's awesome. I think that's a great idea, actually, for depending on the application. But that
Yes.
is pretty cool. As far as the best practices and all that we talked about, that's good to know because a lot of times I know if I go to learn something new, I'll go through several tutorials or blog posts or examples, and yes, I'll learn the thing, but I haven't learned about the thing. Like, why am I doing this? Is this the best approach for what I need to do?
Software is a vehicle for ideas, and if the documentation doesn't expose exactly the idea that it's at play when we design these architectures, then you're operating kind of in the dark. And so we always try to be as transparent as possible about why we make those decisions. And Justin, to your point earlier, we also never add features to RethinkDB that don't scale. So the whole point is that you don't want to be surprised by something. So whenever we add a command to the query language, we will only pick commands and add commands to the language that will fundamentally scale. And we try to design all the features in a way where they can be used with each other. So as you learn a new idea, as it gets introduced into the way that you think about building software, you're able to then reuse that idea in lots of different places. And that's sort of, I think it's important to understand what's fundamentally going on when you start to actually build these kinds of apps.
Yeah, data's hard at the end of the day. Like I think that people underestimate. It's easy when you're writing an example app. I think to some extent on most platformy sort of DB systems, even if it's not necessarily a perfect fit for what you're trying to do. But at scale, I think scale is the key word here because scale is incredibly difficult to deal with. And it's something that, particularly on the web platform, we deal with a lot, right? I mean, we have to have apps that scale out fairly quickly amongst a number of services. And for a lot of developers, that's very hard to grasp in short order.
And as far as like open source projects that are working with Rethink and Rethink DB and Horizon, we talked about React and Angular. Are there other open source projects that are doing interesting things right now with Rethink?
Yeah, so there's a bunch of projects. I mean, so Shipyard is an example of a cool Docker container service that has been using RethinkDB as its backend for a while, and a lot of people who are using Horizon are bringing it to places we would not expect. So Horizon is the kind of technology where basically it makes it really easy to hook it into other node modules and to start to use it in surprising ways. And one of the most impressive demos that I've seen, so Horizon, is designed for any JavaScript environment. It exposes an API by default. It adds things like GraphQL and Falcor as adapters to query the backend. But we don't do specific bindings for specific environments. And the open source community has just responded with trying to bring it to whatever environment they're in. There's a fellow who wrote this library called lovely.js, which it lives up to the name. It's spelled lovli.js. And it makes it dead simple to add a React app on top of Horizon, and all the components are automatically backed. And I've seen some demos of what he's been working on. So you have Redux, and Redux is a really great tool for managing application state. And there's a video I saw where he basically backed the entire Redux subtrees in Horizon with an absolute minimum of code, and then can demonstrate two UIs that are running on disparate environments, two different displays, and then just moving around windows, and they're just being updated on the other side magically. And so all these, because it's just JavaScript, you can sort of figure out now that I can store state and get a real-time updates on that state, what other tools can I start to bring in to integrate? And so I think we're just starting to see the tip of this. I'm looking forward to Angular Horizon because Angular is all observables, and there's a whole bunch of magic that can happen there once you start to have streams you can consume both from the front end and then maybe do some back end work and then push it up to the front end. So I think we're just starting to see some things pop up now. But I would also say that some teams that are fundamentally open, that are building with open source tools, are starting to sort of set the vision for how these kind of tools can be worked with. So one of the most exciting use cases I found out a few weeks ago about, which just kind of blew my mind. So it turns out that NASA has a huge deployment of RethinkDB, Docker, and Node. And the use case for this, a little terrifying, but apparently when you go in space, if you're on the space station and you take an EVA, there's a chance that when you walk out in your spacesuit, you can drown in space because a leak can form, and you can the spacesuit will start to fill with liquid. Now this has happened a couple times, but no one has been hurt, obviously, thankfully. But the thing is, they have these sensors on the spacesuits, and they want to they're building this deployment. One of the ideas is to stream data from the space station, real-time metrics on what's happening. And then with this scalable RethinkDB Docker Node deployment, you basically can react to situations as they come up. And that's huge because if you look at what's happening, it's not just the kind of app they're building, it's the fact that there are 95% of the traffic on the web, I think 97%, is going to be all IoT within 2 years. And so a ton of this data is kind of useless. It's just dumb data that's streaming out. But by being able to take the data that has a transient value that expires in that moment, and by being able to act on it quickly and react to it, you can derive enormous value by reacting to this data whose value will expire momentarily. And so, these kinds of use cases, the kind of models they're building, where basically they're getting just streams of data coming down, and they're sharing how they're building this kind of app. It's actually pretty incredible. And then their vision is that you can then just throw Horizon on top, and then let your JavaScript developers rapidly build apps on top of it, which means that it's democratizing access to these sort of real-time data sets that teams will start to build, both for corporations, for organizations, but I also think for open source. As soon as someone's able to start to build these sort of real-time data sets that are going to be publicly available, and just build these JavaScript apps on top, I think we're going to start to see correlations on all the data that's out there and start to derive amazing results from it. We're going to see some really incredible things.
I remember you talked about that project on JavaScript Jabber when you were live at NGConf, and that was very interesting. I did wonder, are they using this software at Mission Control, or are they using it on space stations or the shuttles and things like that? Because that would be even crazier to have that
would
distance
be.
between.
I always wanted to go to space, so this is for me it was very gratifying to hear about this use case, and it's really cool because they would operate this at mission control. Right now they're working with the sensor data to sort of figure out like how to react to these situations, and what they would do is they would stream data from the space station down to mission control and run it there. You don't want to. I mean, you can do like edge computing if you wanted to. Like you can always like process the data on the edges where your sensors are located and then get the data to your source. But ultimately, like if you can get away with not doing that, you want this to be stateless objects that just sit out there and just spit out data. And then the logic and all would sit at the heart of the infrastructure. And this is how you can, once you have that sort of source of truth, then you can start to correlate meaning from all these real-time streams. And then things get super exciting. Because IoT is definitely one of the most exciting examples for me because it's just so visceral. We build software and we're sort of building glass castles on our head sometimes, and then when you see it in the real world and see it have impact, it's incredibly exciting.
Well, the containers is exciting too because they're so small and lightweight. So now you can put them on a lot of IoT. Not all of it, obviously, but a lot you would be able to, in theory, with Raspberry Pis or however you're going to do it. But
and we've seen a lot of people build those with Raspberry Pis and Rethink. Rethink runs on ARM with a little bit of work, but it can be done, and it's great. I mean, I've built devices on ARM myself on Raspberry Pis, and it's really compelling because you want these things to basically be just the way we write software. You want them to be stateless objects, and containers also encourage that kind of software design and architecture. So I think we're heading towards this world where we really understand how to build things at scale, not just from the technology component, but also from like software design.
Yeah. It'd be interesting to see the challenges faced in IoT with that, and combined with networking, like with projects like Tali and MeshBlue, which I don't know what it's called now, but Citrix has that one. It's I'm talking the networking type of layers for those.
Yeah, I've seen it. Yeah, absolutely. It's incredibly exciting because when you start to add logic to networking, you can really start to get some cool things happen when you know about what's happening within your streams. Yeah.
So Danny, one of our hosts too, he said that. I think it was Danny who did this. He said he loves your mascot, little ghost guy.
This guy right here? Yeah.
Oh yeah.
That's right. I have a painting of this image that we have. So we have a resident artist. Her name is Annie Rugit, and she's unbelievable. She's the full-time artist who just creates art around the open source project. What we discovered was that so just like software is a vehicle for ideas, art is also a vehicle for ideas. So it's important to communicate ideas, and if you can use art to do it more easily and to get people to feel an emotional response, like it really helps explain like why these things are important. So he's a thinker. He looks kind of like this, just like he's stuffed with creativity, a sort of white blob with little eyes. And this is him with Moby, the Docker whale. This was painted in oils. She just painted this and then scanned it in, and so she was originally a children's book illustrator, and when we approached her and said like we would love for you to just become a resident artist and just create art all the time for this project, her eyes lit up because she gets to just like all day long she's making sculptures, she's doing oil painting, she's doing watercolors, she's making illustrations for the website. And we use this as ways to thank our users, but also like throughout the documentation he appears. We just designed the Horizon brand, and we did this. We tried to give a different image and different approach towards art, but still fundamentally include art. So on the community page, you can see this illustration she did for Horizon, which is basically like a take on Sunday in the Park, which is this very classic painting that is hanging in the Fine Art Institute in Chicago, the Chicago Art Institute, and I think it's Servat, so it's like pointillism. And so we try to not just like do service to art, but actually we love art. Like art is a huge part of what we do. And it's cool because from her perspective, she's been looking at what we've been building, and she's like, honestly, having spent time with more software developers, this is not her usual crowd, and she had to sort of understand the community. She's like, they're artists too. They're just sculpting with a different medium. And to hear her talk about it, it just feels like she has a really deep creative connection on both sides. So it's really lovely to see.
You guys are awesome. You're speaking my roots. I come from oil painting and sculpture background, so
right, it's beautiful stuff.
It's pretty awesome.
The other thing is that if you look at security vulnerabilities, because I think it's really interesting just briefly, if you look at Heartbleed, so everyone knows Heartbleed. Heartbleed was like the thing that people, like it was written about in newspapers. The thing is, I think there might have been like 6 more serious vulnerabilities that year in OpenSSL. I think so. Like there were more serious vulnerabilities than Heartbleed. But the researchers made a very wise decision to brand and actually create a logo, like an actual image that you can even maybe in your mind's eye picture now. And the funny thing is that when Shell Shock came out, so Shell Shock is another bash vulnerability. So one of my friends, Paul Gerhardt, who's founder of Lockatron, so he designed like a logo based on the shell icon and put it up on Twitter just for fun, like after Shell Shock came out. And in Twitter search, images popped to the top. And very quickly, journalists started picking up that image and using it for Shell Shock. And the thing is that now people expect security vulnerabilities to be branded. Like, that's kind of crazy, but it happened. And it's because people understand that you can communicate ideas, like you need to pay attention to this more effectively when you use things like art to be able to communicate that idea.
It's very true. I try to do like logos and stuff for open source stuff if I can. And I just really enjoy it. And people will see that and they'll be like, oh, I remember that exactly. I totally get it. So getting back to Horizon, we were talking about. It seems like it's been compared to Firebase and also to Meteor, and I think of those with as very different entities. Can you explain? I know you talked a little bit about it on JavaScript Jabber.
Yeah.
But could you explain the differences?
So yeah, so it's an apt comparison to make to both Meteor and Firebase. Like Horizon is something you would look at when you're looking at either of those options. And I think to answer your question, it sort of pays off to just step back for just a moment and look at how people build JavaScript apps today, just for a minute. And if you look at it, there are three patterns that people employ, three primary patterns. The first is that people go, when they want to get started, like React or Angular, they go on GitHub and they find some seed project. The mean stack, the 3 stack, the LAMP stack back in the 90s, right? And these stacks, the reason why they're compelling is because they allow you to basically take a bunch of common open source tools and get like a standard environment. And it's one that a ton of other people will use. So the mean stack is enormously popular. And the reason why is because it unifies like Mongo, Express, Angular, Node. And it allows people to just, in shorthand, say, I'm building with the mean stack, and everyone knows the expectations that they're stepping in with. And they know how to improve that environment because it's a standard set of tools. The thing is that this is kind of a frustrating experience because if you want to start to add new tools, so let's say you wanted to add like Redux, now you got to figure out how to incorporate Redux into this environment, and you start to see all these offshoots. So there are these million stacks on GitHub that are just these sort of example projects that will just unify a bunch of tools, but they're really based on someone's opinion. And the only way that they become useful is if they gain lots of traction and have a community behind it. Otherwise, you're sort of stuck at square one, having to really understand Webpack and really understand like all these different things, how they fit together across the stack. Do you want isomorphic rendering or not? Like these questions are like complicated and have implications. And so, it's funny because if you step back for a minute, open source has gone through a few revolutions, and it feels a lot like the early days of Linux distributions. Because in those days, you would have these components that people would basically take from, the people just building in a distributed environment across mailing lists around the world. And then they would put them together and say, hey, my neighbor Dave made a distribution for Linux. He called it Puppy Linux, or Slackware, or Mandrake. These ridiculous names, right? But the thing is, like, this is how most people got started in the 90s. And eventually we ended up with polished, like, versions like Red Hat, Ubuntu, that we could standardize on, that like enterprise teams could build with. But the thing is, like, before that, it was kind of this chaotic like mess that it was a lot of fun, but it wasn't very easy to get started. And it definitely wasn't easy to customize it for needs like security or specific environments. So this is what JavaScript development feels like a lot today. You're sort of unifying all these random disparate components and just jumping in feet first and hoping that you're going to have the stack that is you're going to be able to communicate your ideas clearly to other folks. And that it's going to last for a long time. The second pattern, because this is a lot of like headache, and it involves like dealing with databases and Node and like all these like backends. So Firebase and backends as a service like it. The idea of basically taking the entire stack, saying we'll take care of it. We're going to give you a simple API in the browser. Incredibly compelling and very useful for a lot of use cases. Firebase is a great tool, and they just announced like a really expanded feature set with I think Firebase 2.0, I think they're calling it, and it's great because it gives you everything you need to get up and running with your app. And it gives you like all these things that are consumed via APIs. Very compelling when you're building a front-end app. The issue with backends as a service, and this is a trade-off as you mentioned. On the one hand, they're dealing with all the pain. On the other hand, at some point, you're going to grow past the bounds of what you can build with that API. And once you do that, as developers, our tools limit our imagination. And once you go past the bounds of the API, you're back at square one. So people will start to deploy instances on Heroku to talk to Firebase nodes, and it becomes basically just your architecture now includes Firebase as one of the primary components. And so essentially, like once you want to move past the bounds of the API, you're back at square one. And so backends as a service are generally not used for larger applications or things that you expect your needs will change or advance. They're sort of relegated to simpler apps, and they're useful for those kinds of apps. And the third pattern that's really emerged, and Meteor is probably the most prominent example of this, is the idea of the open source backend, that you can basically build a complete backend that's an open source environment and will allow you to get started really quickly, but still do things in the backend should you need it. And so in Meteor's case, how it differs from RethinkDB, or rather from Horizon plus RethinkDB, is that Meteor, what they did about 2 years ago, they set the bar for developer experience. You know, they showed this sort of thing that we now expect now, hot module reloads and being able to like have data flowing from the database all the way to the client with real-time updates. So the way they did that was they took a bunch of open source tools like Mongo and other components, and they tightly coupled them all, and they unified it in this sort of monolithic stack and said, this is how you're going to build it. We're going to use Meteor components all the way up, and you're going to know that you have a standard environment for JavaScript. That's great. Because it really gives you this sort of unified experience. The downside is that it's the Meteor ecosystem. So you either, and again, it's a trade-off. So you can choose to work within that ecosystem. If you want to work outside with sort of the greater node community, it becomes a little bit more challenging. And so, you know, I think in this analogy of Linux distributions, I would say that Meteor feels a lot like open source Windows, right? So it's open source components, but it's a monolithic environment, like a walled garden. And that has its pros and cons. So if some people really like that kind of experience, and some people don't. Our belief is that open source like always finds a way, you know, like life finds a way, open source finds a way. And so you want to be able to take advantage of the bazaar of open source. And so Horizon is much more restricted. It's it stops at the view layer, the data layer. It doesn't make any opinions about what happens in the view layer. And it's designed to be extended in Node in a million different ways. And we expect it to be something that's a lot more fluid. You can use a lot of different environments. You can use it in Electron for desktop apps. You can use it with React Native for mobile apps. You can use it as the backend for basically anything that wants to talk WebSockets, GraphQL, Falcor. And the APIs we expect will grow to support lots of different environments. Wherever JavaScript shows up, we want Horizon to be the persistent data backend, the tools you can rely on that will be a standard environment, a standard distribution for JavaScript modules. Does that make sense the way I've explained it?
Yeah, I think so.
Cool.
Justin, you still with us?
Doesn't make any sense to me. I'm lost. It's all.
That's why I asked. That was I figured.
No, I think you make a valid point. I mean, the monolithic sort of approach, it's not so popular these days. I mean, you see a lot of microservice-based sort of architectures, which is, I mean, really what, you know, if you think of Docker or Kubernetes pods or things of that nature, where you can deploy quickly at scale with these things that, again, don't necessarily give a direct opinion of how you build on top of them. It gives developers a significant amount of flexibility.
And what's the curve for learning this if you come from MongoDB or MySQL or even something like Cassandra?
So when it comes to Rethink, you know, there are a couple of context switches that I mentioned earlier, but it's pretty easy to get started. Because my background is user experience and our team really cares about it, we designed it to be dead simple. So, you know, 10-minute tutorial on the site, brew, install, Rethink, you're up and running with an instant database, and you can instantly start to scale it, shard and replicate from the web UI. With Horizon, we actually designed it to be even simpler. So you don't need to know what a RethinkDB connection is or what Recool is. You just install Rethink, install Horizon with npm install Horizon, and then you instantly can spin up a backend server by typing hz serve. Hz is like Git. You know, it's Horizon. It's our command line tool, and it'll give you instant folder you can drop your static files into. So you just do hz serve, drop your static files in, and start writing your front end app. And all you do is consume these observable-based APIs that are available to you by including the JavaScript tag. So it's dead simple, and I would urge people, like, if you're curious, just follow the tutorial on the site. It's pretty easy to get started.
The FAQ, again, fantastic on the Horizon side as well. The documentation is really clean in terms of getting started.
I have to give credit to Watts, who is our full-time documentation writer, who just works tirelessly to make sure that people can easily understand all the documentation we have on the site.
You know, documentation writers are highly underrated, in my opinion. Massively so. When you have a good one, I know that Arthur, for instance, works on Polymer.
Yeah, if you didn't say it, I would have.
I know. I mean, documentation writers, if your open source project can find one and, you know, get one because they're fantastic and wonderful people who you should send coffee and donuts or whatever, because that's why developers use your product and/or open source project.
And Watts loves coffee. He also is a part-time sci-fi writer, so he writes sci-fi on his own, and he definitely he's someone who enjoys writing fundamentally. The best way to contribute to open source, if you don't know how, write documentation. Help other people understand the ideas you've learned. Share in any way you can.
And the documentation, like I said, is very good. I wanted to know though about mobile stuff. So. On a lot of mobile devices, there's the bandwidth and latency issues, right? And also, a network. So, is there a difference? Like, if you want to go for the Holy Grail of having to share data across all of these devices, maybe even Electron apps across different platforms and things like that, and I don't know if there is an answer for this, but how would you go about doing that to comply with the lowest common denominator and the largest?
So there's a couple points that I'll try to quickly go through to make sure that we understand. So for one thing, the vision of like React and React Native and all these sort of modern JavaScript apps is that you can share 90% of your code base with your desktop, your web, and your mobile environments. And you can just reuse that code, and just the only bits of difference will be the things you mentioned, the sort of environment-specific concerns. And when you have a persistent backend that can kind of be shared across all those environments as well, it's not just that your front-end code is sharing all those resources. It's that your entire backend stack is doing that. And so our goal is to help Horizon be like really useful in all those contexts. Right now, we're working on some improvements. I think they'll make it even better. The things that will help Horizon ultimately will be being able to sync to like a client-side database. So maybe even using a similar query language, so you can cache data and then query it and know that it will eventually be synced in some manner. Similar to things that CouchDB has done in the past for like offline first. Right now, Horizon doesn't have any concept of offline first. We assume the world is just lots of internet, lots of streams all the time. But we're going to be adding things to help with offline support. I think it's very important. And the other is, as you mentioned, there's some data work you can do on like both sides. So Relay is an example of a project from Facebook, which basically its goal is for people on like low-cost phones in India, right? They want to load the Facebook feed, and they want to do a lot of work on the backend server before they even send it up, so there doesn't have to be a lot of requests. And so we're looking at ways to integrate maybe even Relay into Horizon as well, but also to take some of those concepts and to see if we can extend front-end primitives that are really useful that will then kick off back-end jobs. Things like GraphQL as well will help you define what data you're looking for, and then help the entire back-end figure out what's the most efficient way I can work with the front-end and the back-end to deliver that data with a minimum of bandwidth, latency, and worried about like sessions and things like that. So there's a lot of ground to cover here, and I think that like these are all incredibly important tools that we have to learn how to understand first, like what our needs are. And so we have lots of contributions coming in, and we're like really excited to see what's going to happen for mobile with Horizon.
Yeah, I think. Go ahead, Eric. Sorry, I just cut you off. Cut you off right in the middle of your sentence.
That's all right. I do it to you at least 20 times an episode. So go ahead.
Yeah, to your point about tooling, I think it's interesting because I mean tools create both informed decisions, but they also kind of can sometimes pigeonhole you. I mean, you spoke to it to some extent already, but particularly with Horizon, which has a CLI. Thank you, by the way. Justin loves a good CLI.
Yeah.
I know you do too, Eric. But we shouldn't talk about CLIs all the way right now. But tooling overall, though, I mean, do you think tooling's gotten better? I mean, in terms of the web stack today? I mean, because you look at the tools that Rethink has. Rethink has, I think, really good tools, and there are very good paradigms that are out there now that exist to deploy it, to run it, to manage it. Obviously, people are using it at scale, and these things work rather well. But has the overall stack gotten better? Like overall, like are the toolings that are like? Because I always wonder. Yeah. Like everyone seems to have the hammer they like, and that's the only hammer they carry. And I don't necessarily think that that's, I'm a best tool for job sort of person, and put the hammer down, look at the tools in the toolbox sort of thing. But have they gotten better? You think?
I get really frustrated when I see bad user experiences. Like, it really bothers me on like a deep level. And so the thing is, I think the biggest issue is that all the new stack as it's emerging, a lot of these tools want to own the world. And this is really dangerous because, like, so look at Unix, right? Unix is a really well-designed system, and it's being used like as the core for like BSD, OS X, like Linux, for a reason. Because like there are base concepts that you can then reuse in lots of different ways, and it's really easy to know what's happening often because you just have to understand how the system works. And people have come up with a lot of different ways in like 20, 30, 40 years of using the system of like what these ideas should look like. So the problem is that a lot of these new tools that emerge, they want to own the world. So if you look at something like Docker as an example, so I like Docker. It's a good container engine. I like Rocket as well. I think it's really great too. And the thing is, like, a lot of the tooling around some of these new systems, we're basically reinventing the operating system at a higher level, except that these are like harder to use and maybe they don't interoperate well with other environments, and there's a lot of assumptions that are being made. And assumptions are like the most dangerous thing because it means that tools have different ideas in mind and they don't reason about the universe in the same way. And if you step back from just like my rant about user experiences, because that's my own personal frustrations, right? If you want to get started with JavaScript, the amount of work you have to do is absolutely immense. You have to understand, as I said, you start with the front end and you get dragged down to the database. And so I think that, what happens is that when new ideas get explored, you have a Cambrian explosion of open source. You have a Cambrian explosion of ideas. All of these ideas get explored, and then ultimately at some point these tools and best practices get consolidated. And once they do that, it's up to the community and to come up with the best tools that will take those best practices and to make them usable for everybody to really adopt and democratize access to new ideas in software architecture. And so that's like our goal with Horizon, is to sort of consolidate a lot of the chaos that has happened in the JavaScript world. And it's positive chaos. It like creates great things. But you need to like sort of standardize and make the user experiences better. And I think that without that, it's going to be hard to move more people towards building software the right way.
Right. We're coming up on time here. I want to thank you and the Rethink team for coming on, and also for all of your work in the open source community. We really appreciate it. I know I do, because it's nice to have tools that you can use that are free and open source and that you can contribute back to as well. And
thank you. I appreciate that. Yeah, the whole team. This is why we do open source, is because we have that connection with users where they tell us, like, you helped us build these amazing things. Like the fact that NASA is using Rethink DB is incredible, and that really motivates like all the projects we hear about. So if you have a project you're building with Rethink or Horizon, just please come tell us. Like, it's what helps motivate us and keep us on track.
Yeah, I think the next big thing will be the web component that wraps all of this.
Yeah.
So get to work on that, Justin.
It's on my list. There's so many things on my list. So many components to build.
Yes, there are too many. So if people want to find you, reach out to you, or contribute to Rethink or Horizon, or any of the projects you guys have on your GitHub, where can people find you on Twitter, and where can people find Rethink?
Rethink is at rethinkdb.com. Horizon is at horizon.io. You can find me on Twitter at mglukhovsky. It's going to be a long Russian name to spell, but it's MGLUKHOVSKY. You can also just look for the bald guy behind Rethink DB. There's the redhead, who's Slava, and I'm the bald guy. So very easy to find us by the amount of hair we have. And if you want to follow for updates, you can just follow us on Twitter. We're very active. Feel free to reach out to me as well. I always love talking about how people build software, and if you want to contribute, I will always find a way that you can help contribute to these projects. And I want to thank you both for having me on. This has been a lot of fun, and I enjoyed the conversations we've had so far.
You want to learn more about what's coming on next on the Web Platform Podcast? Follow us on Twitter at the Web Platform, or on Google Plus and YouTube at the Web Platform. We also need your help in creating transcripts of the episodes and helping to create open source projects under our GitHub organization. Contact Eric Isaacson at eIsaacson,
or Danny Blue at D_Blue. That's DEE_BLOO.
Thank you for listening, everybody, and we'll catch you all next week.